This is the Microtrainer, a board I created to teach basic electrical principles. In this video, we are going to measure the voltages available at each point in this series circuit. So I have my Fluke 15B plus multimeter right here. And remember to put it in volts DC. I'm going to rotate the dial till it's in the volts DC, the dashed lines and the solid line. And then I need to make sure that my multimeter black lead is in the common port and the red lead is here in volts port. Okay, the next thing that we're going to do is we're going to turn this on. So we have our master switch on right there, and then we have our series circuit on right there. Anytime I'm measuring voltage in a circuit, I want to check the source voltage first. So I'm going to go right here to ground, and then I'm going to go to this B positive. So we have approximately 5 volts available for us at the B positive. I'm going to move next past the switch. So as I measure the switch, I have basically the same amount of voltage available. The reason for that is there should be very little resistance in the switch. This switch should have very little resistance. I just want the current to flow through here when the switch is in the on position. I can dynamically measure that resistance by performing something called a voltage drop test. A voltage drop test is performed by placing the red lead on the closest to the positive terminal of the battery, which is this B positive, and the black lead on the other side of the component. Around 0 volts indicates that I have very little resistance in this part of the circuit. So we see this same value that the voltage went from 5 volts here and stayed approximately the same at 5 volts. This resistor here has some resistance, so we will expect to see our voltage should go down from the source voltage of 5 volts. So if I measure right here, I see that my voltage is now 3.6 volts approximately. So if we wanted to see the actual drop in the voltage, we started at 5. If we do 5 minus 3.6, we should see that here we're dropping approximately 1.4 volts. So 1.4 volts, we go from 5 minus 1.4, and we get 3.6. These components right here, the LEDs, these are the same type of LEDs, so they should be dropping the same amount. I have approximately 3.6 volts, so we would expect this to be around 1.8. If I measure the voltage drop on this side, I get 1.8, and then measure the drop of this LED, I get 1.8. So 1.8 plus 1.8 plus 1.4. So that is an indication that when I add those three up, they equal the 5 volts. So the voltage divides across components, and that's based on the resistance. So this number right here, 1.8, indicates that the resistance of these LEDs at 5 volts is greater than the resistance of this resistor, which is a 1K ohm resistor. So these are greater than 1K ohm, and that's why the voltage is dropping more where they are. These have more resistance, is what it's saying. We could make a calculation and figure out this resistance right here, but the real key point is that the voltage should drop where the load is in the circuit. And in this series circuit, the load is in these 3 components. And so we are correctly dropping all of our voltage, our 5 volts, between these 3 components. We're not dropping anything at the switch. The switch is not a load and should have very little resistance inside it. So these are the kinds of measurements that we could make with voltage on a series circuit.